Hi, this is Mrs. LaBarbara. This is Regents Physics Chapter 2, Video 5. Today's topic is weight. The objectives for today is to know the weight is a non-contact force, weight and gravity are the same thing, and factors affect weight. To understand the difference between mass and weight. To be able to determine mass, weight, and/or acceleration due to gravity, to select, sketch, interpret graphs of weight versus mass to determine acceleration due to gravity. Gravity force, Fg. Gravity is non-contact force. It is a vector quantity. Non-contact means you don't have to touch it in order to exert the force. It is attractive force. Attractive force means toward each other. Between the Earth, Moon, or other massively large objects. All objects on Earth experience a force of gravity that is directed downward toward the center of the Earth. The force of gravity on Earth is always equals to the weight of the object. That means gravity force and weight are the same thing. Factors determine weight. There are two factors determine weight. One is m, one is g. M is mass, which is the amount of matter in an object. G has two names, gravitational acceleration, also known as gravitational field strength, which is determined by the location and the environment of the object. G equals to Fg over m. This equation is in your reference table. We can rearrange it to find weight or gravity equals to mg. What is G? Two names for G. Again, gravitational acceleration or gravitational field strength. It is determined by two things, environment and location. On Earth's surface, the Earth is the environment, the surface is the location. Acceleration, G is 9.81 meters per second squared. Another name for G is gravitational field strength is 9.81 newtons per kilograms. So because the two are equivalent, so Newton per kilogram is equivalent to meters per second squared. On Earth, we can approximate G equals to 10 meters per second squared. So when you have to do estimation, you can just use G equals to 10. Note G is different with different environment. So on Earth's surface is 9.81. On the Moon's surface is 1.67. On Mars' surface would be 3.71. Comparing mass and weight. Mass of an object refers to the amount of matter that is contained by the object. It is a scalar quantity. That means it has no direction. The mass of an object will be the same no matter where in the universe that object is located. Weight is force of gravity. So force is a vector quantity. Its direction is always downward. To figure out weight, we need mass. W equals mg. Remember, W equals mg, that's because weight and gravity are the same. The weight of an object will vary according to where in the universe the object is. That is because G varies. So here are estimate questions. 1 kilogram is about 10 newtons. 1 kilogram is also about 2.2 pounds. 1 kilogram is about 4.5 newtons. An example, the diagram shows a 5 kilogram block at rest on a horizontal frictionless table. Which diagram best represents the force exerted on the block by the table? So because this is a force exerted on the block by the table, the force has to be upward. So the only logical answer could be A and C. Next one is force. What is the unit for force? Unit for force is newtons. So the answer is A. Weight versus mass graph. W equals mg, weight is directly related to mass, so the graph is a straight line. Now this slope is represented by g. So g is the slope. What is g? Gravitational acceleration or gravitational field strength. G depends on location and environment. Let's do a couple of examples. What is the weight of an object with mass of 30 kilograms on Earth? Well, W equals mg, plug in the equation, you will have 2.94 newtons. Next one, what is the weight of an object with a mass of 30 kilograms on the moon, where g equals 1.67 meters per second squared? Plug in the equation, you will have an answer. So the example for this is to illustrate, even you have the same mass, they weigh different because g is different. Another example. Different masses are hung on a spring scale calibrated in Newton on Earth. The force exerted by gravity on 5 kilograms is about 50 newtons. 1 kilogram is about 10. The other one, how many kilograms will be 100 newtons? That's 10. The force is on 70 kilograms is 700 newtons. Next question, a 50 kilogram mass weighs 60 newtons on planet X. So you know the mass, you know the weight. So the mass is allowed to free fall from rest near the surface of the planet. After falling for 6 seconds, what is acceleration? Well, if you know the weight, you know the mass, you can figure out acceleration. You don't need a time. So acceleration is weight divided by mass, 4 meters per second squared. An estimation question. The weight of typical high school physics student is closest to, so physics doesn't really matter. So a typical high school student is about how many newtons? Now, we're not really familiar with newtons. We're familiar with pounds. So average high school student is about 150 pounds, say. So how is the pounds, kilograms, and newtons are related? So 1 kilogram is about 10 newtons, 1 kilogram is about 2 pounds, 1 kilogram, say, about 5 newtons. So 150 pounds person would be about 750 newtons. Then you probably say, hey, there's no 750 here. How do I know what the answer is? So when there is no answer matches your answer, C here is closest to. So which number is closest to 750? So the answer is B. Another example. The weight of a chicken egg is mostly nearly equals to how many newtons? So this is, you have to memorize this. An apple is 1 newton. So chicken egg is about the size of an apple or have the same mass as the apple. So it is 1 newton. So 10 to the 0 is 1. Question about mass. Which of the following statements are true of the quantity mass? List all that apply. A, the mass of an object is dependent upon the value of the acceleration of gravity. False. The mass is the amount of matter in an object. B, the standard metric unit for mass is kilograms. That is true. Mass depends on how much stuff is present in the object. That's true. That's the definition of mass. Now, mass of an object is variable. It's dependent on its location. False. Mass doesn't change. E, an object would have more mass on Mount Everest than the same object in the middle of the Lake Michigan. No, mass doesn't change. F, people in Weight Watchers are really concerned about their mass. That's correct. G, mass of an object can be measured in pounds. That's probably, you probably say, yeah, that's true, right? No, well, pounds, that's really is a unit to measure force in British units. So that's incorrect. Next one, if all variables are equal, then an object with greater mass would have a more difficult time to accelerate. That's correct because mass is a measure of inertia. Inertia is resistance to change. So the more mass you have, the harder it is to accelerate. I, if all variables are equal, then it would require less exerted force to stop a less massive object than to stop a more massive object. So this you probably can conclude from your daily experience. Think about a toy car and a real car. Both are moving at the same speed. So which one is easier to stop? Obviously, it's toy car because it is less massive. So this is correct. Last one, J, the mass of an object is mathematically related to the weight of the object. That's true. W equals mg. It's a math equation, so J is also true. Example. Big Boy has a mass of 100 kilograms on Earth. What is Big Boy's mass on the Moon, where the force gravity is about 1/6 that of the Earth? You need to explain. Well, it is also 100. That's because mass does not change. A person weighs 785 newtons on Earth's surface would weigh 298 newtons on the surface of Mars. What is the magnitude of gravitational field strength on the surface of Mars? All right, so let's see. We know what doesn't change is the mass. So weight equals mg, mass equals weight over g. Since mass remains the same, so the mass on Earth equals the mass on Mars. Mass on Earth is 785 divided by 9.81. Mass on the Mars is 298 divided by g, the gravitational acceleration on Mars. So you can solve gravitational acceleration on Mars is 3.72. That's it for today. Thanks for watching. See you next time.